ActiveMQ. I'm also involved in some other Apache projects and helped found Camel and Service Mix. I'm also on the JBoss USer Group. So you can't see all of this slide, but this is like the history of Fuse engineering. FuseSource was acquired by Red Hat, and the acquisition went through October last year. So we've been with Red Hat now for 9 months. But our journey started off in 2004. I did the first implementation of ActiveMQ, and it went into Codehouse. And we've actually formed an open source company called Logic Blaze to actually support ActiveMQ and other integration projects. We've always had this big scheme of things to actually provide messaging and integration solutions. And from my mind, where you start off is you've got a good foundation of messaging. Messaging is one of the key components for any integration solution. So we added CXF, we added Camel, we were acquired by lots of different companies along the way, including Progress Software, we spun out FuseSource, but our majority shareholder was still Progress Software, and they had some trouble and decided to sell any asset they had. We've ended up at Red Hat, and we have a great time here at Red Hat. So why would you use messaging? Well, if you don't know, it's really because it provides a level of independence between your applications. It provides robustness. It means that you can have asynchronous interchange between applications. It's kind of language neutral as well. The first messaging system of any real commercial value has been MQ series, now called Websphere Mq. But that started off in about development started off in the late 60s, but commercially available early 70s. And that's the model that most message brokers have used to date, and certainly the model that we based ActiveMQ on isn't exactly on Websphere Mq, but it's followed those guiding principles. So ActiveMQ is a top-level project at the Apache Software Foundation. It's been at the Apache Software Foundation for a good 6-7 years now, but it took us 2 years almost to get through the incubator. And this is one of the problems that the Apache Software Foundation has in general. When you go into the Apache Software Foundation, they need to make sure that you're operating in the Apache way, and that means lots of different things to different people. But basically it means that there's going to be a collaborative process, it's community over code, there's going to be no one single party really driving the software. But actually, in reality, that's always the case. You're always going to get an individual or group of people who actually drive a project. If it's all done on consensus all the time, nothing would actually ever get done. So, just to make sure we cover the basics of messaging. Does everybody here uses ActiveMQ? Or have used ActiveMQ or understand messaging? Pretty much. Okay. All right. So, in general, it's an association between message channels, destinations. They equate to destinations in JMS. Some people call them message channels. JMS destinations break down into 2 distinct things, topics and queues. But the reason why you have message channels, they're kind of like TV channels, channels you tune into to get particular messages. So if you're only tuned in or only subscribing to a particular queue, a particular topic, you'd only receive messages for that queue or topic. And it's a way of actually segregating and routing messages between clients, between a producer and consumer. And just so we're all clear, a queue has some distinct semantics, which are anything listening on a queue will only receive one copy of that message. And if you've got multiple consumers who will round robin around those interested consumers. Now, it's not exactly round robin because there's other things which are taken into account, like how busy that consumer is. So inside JBoss A-MQ or ActiveMQ, it's keeping a running tally of how many messages a consumer has and how active it is. So if it's a really slow consumer, it will stop sending messages to that slow consumer until it's actually started to consume more messages. The reason why that consumer may be slow may be a number of different factors. It may be the network, it may be that actually what the consumer's doing with that message takes a long time to process. So as opposed to queues as topics, And with topics, all messages get broadcasted out to any interested consumer. So those are the basic constructs of messaging. You can we actually enhance that. This is part of the JMS specification. Hopefully you can see off the far end there. But you can actually, as well as tuning into channels, destinations, you can then be more selective on those channels by applying selectors. And though you can't see it, there's two consumers here. One's accepting colours red and one's accepting colours blue. So the messages will get routed to those based on the selector they apply and give to the broker when they start to consume. But that routing actually happens at the broker on the destination. So it's no client-side filtering, it's all done on the broker, which means it's quite efficient. Excuse me, I've got a bit of a cold. So in addition to being able to send to distinct channels, filter on those channels, there's also something we also support in ActiveMQ, which is wildcards and wildcard destinations. So this consumer is saying bar.greater than. Greater than sign, which unfortunately you can't see, means I want to describe to everything on this destination name after bar. And there's two kind of wildcards we support. We support a star. So if you have an element name, bar, star, food, you'll subscribe to anything which was bar, say, chips, food, as opposed to star, which is everything. So in this particular case, this producer is going to send to a topic bar wine, and because that consumer is subscribing to topic bar greater than, it will receive that message. So I'm just going to go into some features that ActiveMQ has, and a lot of other message brokers have, but I think it's something that every message broker should have, but there are some which don't. So the first thing is exclusive consumers. Now, we talked about queues and the fact that messages are robbing around different consumers. With an exclusive queue that's kind of thrown away, what happens with an exclusive queue is that all the messages go to one consumer. And the reason we build that into ActiveMQ is because you might want to have guaranteed orders of messages. So when messages come in, you want to make sure they're processed in the same order. If you rely on the queue semantics to send out in a round-robin kind of way, because it's done asynchronously and you've got threads involved and networks involved, it means you can get messages out of order, even on the same connection if you use in different sessions. Every session on the consumer side has a different thread associated with it. So an exclusive consumer is a way to get around that by saying, I only want one of those consumers to actually get all the messages. Now, why would you have more than one? Well, the idea of having more than one is if that consumer should die or not be available because the network's out, then another consumer can take over. It's inbuilt master slave, and a couple of patterns that people use, they're using something like exclusive consumers to provide a master slave or locking an application. So we can extend that concept out with message groups. Message groups are like exclusive consumers, but instead of having one consumer accessing all those messages, we actually break up the messages based on their group ID. And the group ID is set by a producer, so you actually have to involve some application thought and programming into this. But you set a group ID, for example, it might be a stock price, it might be TIBCO, it might be Red Hat. And every message on that group ID will be consumed by the same consumer. But just like exclusive consumers, if that consumer dies, the message broker will select another of the consumers who are interested in that particular queue and then start sending messages from that group to that particular queue. So it's a very efficient way of actually breaking up message load across multiple consumers, but making sure that only one consumer is active on that particular group, so you ensure there's going to be message order. This is just a tip. When we send messages synchronously, which is the case of persistent messages, when this kind of thing happens, oops, do that again. You can see from that representation that actually when the producer sends, it's waiting for an ACK from a broker. The message broker won't actually send that ACK back until that message has been persisted, if the message is marked as being persisted. But then it would send the ACK back to the producer, but at the same time, concurrently, we send that message out to consumers. There are some optimizations we do around that, actually on the broker side. There's some broker side options, but on the client side in particular, you can do things like don't send sync, always send async, which is very fast, but also fairly unreliable. We do good things into ActiveMQ to make sure that we can resend messages. So we try to make it as reliable as possible if we lose connectivity to a message broker. But actually, the best thing to do, and this is jumping outside of the current JMS 1.1 stack somewhat, is to send this asynchronously. So you can add a callback. And actually, if you use a callback mechanism, you get the benefits of a guaranteed delivery to the broker. But because you're not doing that context switch on your producer side, and you're waiting for that callback to happen, it's actually about 20% in general, 20% times faster, between 20 and 50% times faster to do it this way. Deploying JBoss A-MQ, and I'll talk about JBoss A-MQ and how that relates to ActiveMQ towards the end of this presentation. There's different ways you can deploy. One of the reasons why ActiveMQ / JBoss A-MQ got so popular is because of all these deployment options. You can deploy it standalone as part of a highly available cluster. The biggest thing that we found is running ActiveMQ embedded, which means you can run it in JUnit tests. So it's kind of a default messaging system that people who are using Java use doing tests. You don't have to use mocks, you can actually use a real message broker when you start up in your JUnit test. So it started to become popular that way, and its usage has grown and grown and grown. A bit like Tomcat, it's like the default message broker people start off with. And for most cases, it's more than good enough. So let me jump into message storage. Now I mentioned briefly about message persistence. You mark a message as being persistent, then the message broker will always store that message for queues. For topics, it will only store that message if there's an interested durable subscriber. Now, the current model in JMS 1.1 is slightly broken, really. Durable subscribers in themselves and topics aren't particularly that useful because you're only going to have one durable consumer on a particular queue. The durable consumer is earmarked by its client ID and subscriber name. So you can have multiple durable subscribers, but only really one per client. So that client's not active. It's not like you can substitute a slave to take over from it. So you can get messages hanging around waiting for an application to come up. That's kind of fixed in JMS 2, which is probably scope for a beer, and not for this talk. But really what I want to talk about are some of the different messaging persistencies that ActiveMQ offers. By far the most popular is SQL or JDBC. There's a lot of deployments who use Oracle. You've got an enterprise relational database in-house, you want to reuse that. The benefits of doing that is you've got sysadmins who know how to set it up, they know how to optimize it, and they're very happy with restoring it, backing it up, etc. General administration. Downside of it, it's pretty slow. Then we've got two that so we keep on trying out new different message store implementations which are local to the broker. These two, AMQ Message Store and Kaha, have been around since, the first one, AMQ Message Store, has been around since version 4. Kaha was introduced in 5.0. We depreciated those, and the current one is KahaDB. But we're going to be introducing LevelDB. It's in the current version of ActiveMQ. It's like a tech preview. There's going to be a top level, not the default, almost the default. It will be in 5.10, it will be the default message store. And let me explain the reasons why. It's heavily optimized. LevelDB is actually created by Google, but it means we get fewer index entries from KahaDB. Basically, the index outperforms the B-tree index we currently use, which means we get vastly improved results. And this graph is actually showing KahaDB versus LevelDB. The higher on the graph, the better. And we're doing this with very small message sizes, really so we can emphasize the performance of the database, not the performance of the disk, and actually storing that message size. So that's something we're rolling out. It's already in 5.8, but it will be supported in the next version. And we also support a lot of different message protocols as well. OpenWire is the default. It's a binary format. It's fast. It provides a lot of functionality actually in the message format, which is used between broker and client communication, and it's for default for ActiveMQ. Disadvantage is though it's not standard, and it only works really with Java and C and C++. Another interesting one, which is really what I'll be focusing on when I do the demo at the end of this, is Mqtt. Who's heard of Mqtt? It's a new standard. It's a machine-to-machine telemetry protocol. It was designed and implemented by IBM first off, but now it's becoming an Oasis standard, and they're using it to talk to embedded devices. And the reason this has become so popular recently is because Facebook use it as a messaging protocol between their back-end servers and their mobile phone clients, because it's so efficient. I'll talk about that later on. So Mqtt only support topics right now. There's an awful lot of clients for it already. I'll be demonstrating one based on C on an Arduino device. Then there's AMQP, which I'm sure most of you would have heard of. That's 1.0, and ActiveMQ supports the 1.0 standard. And there's, I think, currently 2 or 3 message brokers which support 1.0. One's Cupid, one's ActiveMQ. We're using their code. And I think they've got a default implementation too, which is really Python. The downside of using AMQP 1.0 right now is that most of the AMQP clients out there are not 1.0. They're using RabbitMQ, using 0.91 or 0.10. And until we get a lot more 1.0 clients out there, it's not going to get widespread adoption, and RabbitMQ aren't going to adopt it until there's more widespread adoption. So it's a bit of a catch-22. But we're working with other Apache projects, particularly Apache Cupid, to roll out more clients out there. So they're going to be rolling out a Python client, Perl client, C and C++ client this year. And our customers that we currently have, they all want the 1.0 version because it's a standard. And none of the previous versions of AMQP were really standardized. Then there's Stomp. Stomp is probably the de facto standard for any message broker. All the current open source brokers support it, and there's some commercial vendors who support it too, like Oracle support it. Well, they don't support it, they provide it in their message broker. And there's other stuff we support too, like WebSockets. So WebSockets we support out of ActiveMQ, and we can lie Stomp on top of WebSockets as well. And we're just introducing Mqtt support on top of WebSockets in the latest release, which is coming out in a couple of months, which will be 5.9. The reason why people want to use messaging and WebSockets is because they want secure communication right from the back end right to the mobile clients. And in fact, we have a number of large customers who already do this. And some well-known brands like Coca-Cola use WebSockets with ActiveMQ because we provide security, SSL, and they can communicate that to that using JMS. So we can go JMS straight to WebSockets to a mobile client to give them updates. So it's quite a simple programming model to do that with. So let's talk about some enterprise features. One of the first things is high availability via client failover. So we automatically handle this scenario in our Java and C++ clients. When you have a disconnect with the broker might have gone away or the network might have disappeared, the client side will automatically detect that as a keep alive going between the client, producer or consumer, to the broker, so it can detect if the network's gone away or the broker's died. Anytime it gets any socket errors, that's also fed into that same failover protocol. The client itself can keep a snapshot of the messages it's sent across to the broker. If it sends it synchronously, then it's only going to be one at a time. If it's sending asynchronously, it's going to keep a buffer. I mean, when it reconnects either to the same broker or to another broker in that cluster, it's going to resend the messages which didn't get there successfully, didn't get an acknowledgement for. So when it sends those, it was sending like a window of messages. There's always a chance you could get a duplicate, but in the clustering, the brokers actually look for duplicates. Every message has a globally unique ID, so it can keep a window of IDs or secret numbers that are passed around the cluster and discard ones that it's already seen. And just as an added safety feature, clients do the same thing too. And then the high availability options that we provide are, there's two types, there's three types. Let's run out to two types in the current release. Master-slave based around JDBC or an Alpha database. And then a shared file system. And then for the 5.9 release, which is coming out in 2 months, we've introduced a replicated configuration which is based on level DB. So with JDBC, we have this kind of scenario where we're sending messages to the master broker, but they've actually disappeared. The ActiveMQ client will carry on, file over to a slave, and that slave will then carry on passing messages. And the key thing here, unfortunately, is even though you can have lots of different brokers enlisted into your highly available network, you've got to have a shared resource, and that's the database. So that's relying on locking a database, be it Oracle or MySQL, clustered MySQL, for example. So it's extremely reliable, but not terribly fast. We do have a number of deployments of people who are using this because when they use it where performance isn't that critical, they just want to guarantee the message is going to get there, and they want to make sure that it's going to survive any disaster scenarios. It's a very simple configuration. And you can configure the lock key play. So what happens is all the masters, they actually try and grab a lock in the table, in the database, and the first one to grab the lock will then become a master. And if that dies, it doesn't keep the key alive to keep that lock, and another broker will take over and then become a master. So we have a similar scenario with a shared file system. Again, we've got many brokers, but only one will become a master. So it'd be sending messages to that master, and the slaves would be hanging around not doing very much. And when it was a disaster scenario, like a truck hits your broker, then it will fail over. But again, you're relying on shared storage, either distributed reliable block storage or SAN or NFS. NFS version 4 is recommended. The key thing here is whatever distributed file system you use, you've got to ensure that the locking works well. The problem we've had with GFS when we've looked at that is actually distributed file locking is very flaky, and that is not guaranteed to work. So you can end up with two brokers, both think can make up the lock and both actually become active, and you have a very confused message store. This scenario, which is replicated level DB, and just off the corner here, just over there, there's Zookeeper. Do people know Zookeeper? It's used as part of Hadoop. Zookeeper is a way of making sure it's a very reliable system for ensuring you can have reliable state. And actually, that provides an independent locking mechanism. So first of all, these brokers will connect to Zookeeper and try and get a lock. So we select one of these brokers will be selected by Zookeeper to become a master, and so we send messages in the same way. And if that dies, then I missed out a state there. But what happens is that broker on the end will then poll Zookeeper to see if it should become the master or not. It's granted the master status, so it then becomes active. The client will fail over to it, and he will be able to carry on sending messages. Now this is more reliable than any of the other systems because instead of relying on shared file locking, you're relying on Zookeeper or Zookeeper cluster. So you get no single point of failure. Zookeeper is normally deployed as an ensemble of between 3 and 5 nodes in a cluster. It also means that Zookeeper as well, as I do more of this talk, you'll find out it's actually involved very heavily in JBoss A-MQ and other JBoss Fuse products. So it's going to be there in the system if you're using JBoss A-MQ anyway. And it provides a very simple configuration, but it also provides a mechanism where you can have more control over how you do the replication. So you can decide if between those nodes, and each one, if I go back again, the difference here is they don't have a shared file system. Each one has a copy of the database they're using, and they're replicating between each other. So that one would be replicating off a master. Just jump back again. So that's the master node. Both the slaves will replicate off it. But if they're on the same data center, you could decide that you want this to be synchronous. You want to utilize the network capacity you have. But if this broker over here is actually in a completely different data center, you don't have the same bandwidth, you might decide to take a chance and send that asynchronously to that particular broker. So you may miss some messages in that case if you lose both your master and your broker on the same data center, but at least you have that choice and you have more flexibility in how you design your replicated high availability broker networks. Let's skip over that again. I'll talk a bit about network of brokers now. Actually, you can see both of those. So network of brokers is something we call for store and forward messages, where messages go from one broker to another. And by default, networks are like unidirectional. So they only go one way down when you establish a broker connection. But the problem is, if you have a firewall in there, in place, you think at your remote site trying to dial in through a firewall, you're not going to open up a firewall to lots and lots of different brokers. You want this to actually be bidirectional, and that's an option that we provide too. So you can actually, what would happen is, you'd have a well-known port, so your local broker could dial in through a well-known port to a remote broker. The remote broker would reuse that network connection to send messages backwards and forwards. So that's not on by default. You actually have to set in your network configuration the option duplex equals true. And by default, a lot of users actually do that. Now there are some problems with using networks. There's a lot of chatter. Every network, when the network of brokers is set up, every broker knows about every other broker's subscription, what active consumers it has, and it sends those information as advisory messages. So if you've got 1, 2 or 3 brokers, that's not a problem. If you've got hundreds or thousands of brokers, that does start to become an issue. In fact, the biggest deployment we have to date of ActiveMQ is in the thousands of brokers. It's by a retailer in the United States, and every store they have has a network, has a broker on it, and they're all connected together. So we have to take some care in making sure we filter out where these messages go, where the advisory messages go around this network. And that's something you can actually physically do in the configuration itself. And here there's a number of different options you can do for filtering. But here you're saying, I want to pass on these particular queue names to other brokers which are connected to my network, so I'm now going to filter those messages across. So that's okay. It's not perfect, but it's okay. And something else that we do with store and forward is that we can actually choose the most efficient route for messages. So if you've got a cyclic network, you've got 3 brokers, for example, connected together, ActiveMQ can choose the shortest hop, so it just go directly. If there's a failure on that link, it can go choose another route to get to the same broker. Now the configuration to do that is slightly complex, but it is possible. But it starts to get more complex when you want to do things like you have firewalls and you have a master-slave kind of scenario. They're on both sides of the network. It means that both the master and the slave have to know about the opposite master and that slave. And on this side, this master has to know about that master and that slave. You can see it starts to get very complicated very quickly, especially if you have thousands and thousands of brokers. So scaling networks of brokers is relatively hard, and it starts to get problematic when you get lots of brokers. We can do filtering to shape that, but it does involve a lot of manual configuration, a lot of upfront thought. However, let's get up there. However, there is something called Apache Camel. People heard of Apache Camel? Yeah, good. Okay, what we recommend to people to use is actually to do some of that filtering and routing by using Apache Camel. And you can actually embed Apache Camel in ActiveMQ. And it makes a lot of sense. Camel actually came out of the ActiveMQ project. This is one of the reasons it was created, to provide more flexibility to the message broker in ActiveMQ. And by default, ActiveMQ itself ships with Camel Core, Camel ActiveMQ, which is the component connector to ActiveMQ, and JMS. So it means it's very simple to do things like filtering on messages, content-based routing on messages, and bridging to other messaging systems. So if you have a JMS implementation saying Websphere Mq, it's very simple to use a message broker from ActiveMQ to directly bridge to Websphere Mq. And that's something that we recommend people do, rather than use the bridging, which is part of the ActiveMQ deployment itself. Always use Camel. In fact, always start off with Camel. So there's more problems actually with ActiveMQ. There's problems about installing at multiple hosts, about having to copy your own configuration files. Doing manual configuration of our configuration files is time-consuming, it's error-prone, and when you come to upgrade brokers, it can get problematic. Now, there are things that we recommend that you do to avoid that. So use templating, try and keep your configuration in a source control system so you can roll things back or things go wrong. And there's also problems then for your clients too. It means your topology suddenly becomes very static. You have to configure your clients to know exactly where those brokers are. Hopefully they're on well-known ports and addresses, but they may not be. You might want to have flexibility where you can move a broker physically from one machine or one network to another network. And ideally you want those clients to find out where those brokers are moved to, and an easy way to do it. So we started this project about 3 years ago almost now, called Fuse Fabric, which is actually like it's like a PaaS, but it supports there's 3 different components to it. There's the agent itself, which is deployed onto a physical machine, be that bare metal, on-premise or on a public cloud. Then there's a registry, which is a runtime registry, which all the agents know how to talk to. So they all talk to a registry, which is actually based on Apache Zookeeper. And actually, any clients can talk to that registry too, so they can discover things like, where's an ActiveMQ broker running, where's an Camel endpoint running. And because they're held in a central registry, it means that you have things built in like failover, high availability, location independence. And then we have tooling, developer tooling and client and web-based tooling to control and configure those agents. So I won't go into too much detail, but basically it allows you to configure a profile for, say, you want ActiveMQ and Camel to run together. You can configure that profile and roll it out to 1, 2, 3, 4, 5, as many agents as you like, as many agents as you have in your fabric. And you can do updates on that profile, so when you configure the profile centrally and hit do an update, you can control how that update goes out to your agents too. You can do a general all-encompassing update, or you can do a rolling update, you can do one at a time. So it gives you more control over your environment. And when we look at FuseMQ is actually it's an open source project, which is ActiveMQ combined with Apache Karaf. But it's got some features which have been installed in addition to Apache Karaf. Apache Karaf is an OSGI container. These are the fabric features and our profiles to design the basic ActiveMQ or FuseMQ features. But we bundled this all together into a product which comes out of Red Hat. It's called JBoss A-MQ. And this is built and designed around ActiveMQ 5.8, but it combines the carafe container and basically the FuseMQ project I just talked about, provides all that in a productized version so we can control the rollout of that software and provide support around that software. But some things in addition to that we provide as well. We provide an IDE, which is called Fuse IDE, which is embedded into JBoss Developer Studio. And we also provide a Fuse Management Console for doing configuration. It's a web-based console. And we also provide John, which is the JBoss Operational Network, for doing metric monitoring and logging and alerting on your JBoss A-MQ cluster. The benefits of actually going with a product from Red Hat. The first one is going to be supported. We're going to do updates and patches in production for you, which is different than absorbing this just as open source projects. Because if you take things from the Apache Software Foundation, there's a couple of gotchas in there which means it's not ideal to actually run in production. The main one is, every time you do a release, it's got to go through a voting process, which must run for a minimum of 72 hours or 3 days. And it more often than not takes a lot longer than that, because you need to hopefully get consensus in that vote. You don't want anyone to give you a -1. So if you're running in production and you suddenly have a production issue or security flaw that you come across that you need to be patched urgently, it's going to take at least 3 days for the Apache community to turn that around, even if they were available to do that just as soon as you send that email into the list saying, I need this fixed really quickly. The reality is it's going to take several weeks, which is why we do our own distributions of ActiveMQ and incorporate them in JBoss A-MQ. Okay. So where's it used? I'll give you some examples. There's a big energy company in the US who are using it in a smart grid. They're using directly JBoss A-MQ and JBoss Fuse, which is our ESB, which is based on Apache Camel, to provide smart grid integrated technology, not only out to homes and devices, but also as a seller to other partners of theirs. This is actually GE Energy who use this. Another interesting project that uses this is the Federal Aviation Authority. They use JBoss A-MQ and JBoss Fuse together to control how they route information to the planes directly. They have a next generation air traffic control systems has direct communication to the aircraft where they got that installed, to update them on weather information, to update them on flight data, control data. And that controls every aircraft which enters, every commercial aircraft, non-military aircraft which enters US airspace above 10,000 feet. Under 10,000 feet we go over to control of the local airport. But over the next 3 years, I think the FAA are going to start controlling that airspace too. And another place that JBoss A-MQ is being used is actually in space. Actually, on the ground stations for the Mars Explorer which landed last August. That distributes raw data from a ground station to any interested laboratory. It's about 200 round for globe. It's just not NASA who are listening to this information, but other universities and other scientific centres and schools, etc., universities are listening to this information. And then finally, the biggest one to date has been, well, my favourite project anyway, it's not the biggest deployment we've got, it's my favourite project, which is the Large Hadron Collider at CERN, and JBoss A-MQ is actively used to help distribute, control the positrons and the flow and the rate of those positrons as they collide in the Large Hadron Collider. So nothing's happening about at the moment because it's all turned off as they're doing a maintenance cycle. That's going to start up again next year.
Isn't it because of maintenance of ActiveMQ?
Well, actually, ActiveMQ has kind of brought it down, like, I think at least once, I think. But bug that I introduced, and I'll tell you about that over here. But I'm kind of semi-proud about that. But. So why is integration and messaging important? Well, particularly nowadays, people want to know more and more about what's happening in their enterprise. And the enterprise reach is extended out not just to bricks and mortar, but extends out also to the consumers, where the consumers live, what they're using, mobile devices. And then further afield, if we think about other areas of integration, people are integrating now in the cloud, so software as a service has got very big. The reason for that is there are 10,000 SaaS providers, 5,000 public APIs, and that's growing by 500 public APIs every single month. So it's growing very rapidly. And then there's the Internet of Things, the things I was talking about before. Every device which is connected has an IP address on the network. In some way you want to actually be able to communicate with that. So let me give you some examples. Actually it's not on this slide. But basically you want to collect this information and do it in a really efficient way. And if you look at the number of things that are actually on the internet, to date it's just about the same number as the population of the planet. It's about 9 billion. But by 2020 it's going to be 50 billion, which is going to be a considerable number. So some examples of M2M is smart energy, so you actually have these embedded in meters, in houses. And this is something which is being rolled out, actually in the UK as well, but also in the United States and other places in Europe. Inventory control, obviously, which started off with RFID, which is really the crux and the start of the Internet of Things, but it's being rolled out to mean so much more now. Vendor machines inside vehicles, so German manufacturers like BMW and Audi are looking at having devices in the, well actually we already do have devices in the car which will monitor the systems, and they can dial out to your local dealer and tell them you need a service now, so they can phone you up and tell you need a service with them. I was speaking to somebody at Red Hat Summit who's working for Airbus, and they want to put Mqtt enabled devices on every new plane they do, so they can communicate with and register all the flight information, the things which are normally recorded in a black box, but so they can distribute that out when the plane lands at an airport. So it means that they can be more efficient in terms of how they do maintenance on that aircraft. And probably my most favourite one to date of an M2M example is someone has got a small device which they've attached to their cows, milking cows, and they're using Mqtt to communicate back to the farmer, telling the ideal time to go and milk that particular cow. So that's very interesting. I'm not sure what the cow thinks about that. So this is a typical M2M topology, and it can either be an interconnected mesh network. So actually these devices will all be communicated themselves, and one would be then allocated to be the one which will connect to a gateway device and onto the internet and onto the back-end system. And the thing is about when you collect in so much information, the other way is using a mobile wireless network. When you're collecting so much information, you need to do something with it. And typically people today actually storing all the information from all the devices they're using into a big data storage like typically you do, actually. So they can do analytics on it at a later point. But one of the big things about Mqtt and why it's suddenly become fairly hot at the moment is its to do with power consumption, not only an embedded device, but also mobile devices too. Battery life is really important. So when Facebook looked at the most efficient protocol they could find for doing real-time updates, they ended up choosing MQTT because it was more efficient than using straight HTTP or using WebSockets or any other form of doing push out to a device. So for that reason, MQTT has suddenly got a big uptake, not in just for machine to machine, but also from back-end to mobile client too. And because of the deluge of all this data being passed around on messaging networks, it's not just about integration, but messaging is also very important too. It means that a lot of this information has to be stored and processed in a very fast way. And in fact, one of the companies we work with was the inventor of Hadoop, and they use ActiveMQ, and they actually helped us tune LevelDB to the performance it has now to read information from all their web servers, and we've got 14,000 of them. And we want to collect all the access information as people hit the Apache web servers, because they derive billing data off the click-throughs. So we want to secure that information securely, reliably, and extremely quickly into Hadoop. And we're using ActiveMQ to do that. So what we need moving forward is really a complete infrastructure, need an ecosystem of integration. It's just not just about messaging, it's not just about having an ESP, actually you need both. And you need a whole plethora of different protocols. So in the particular architecture we provide, we recommend that CAN is used to do the integration on the edges. You can use something like ActiveMQ or FuseSource to do the message routing. And actually, FuseSource is used to provide high availability for Apache Camel deployments anyway. And then something like Fuse Fabric to do the centralized management and runtime topology control of that deployment. What I'm going to try and do is actually this kind of scenario where we have a device which is connected over MQTT going to a gateway or router which is using AMQP as a message protocol and MQTT. It will then pass over AMQP to an ActiveMQ broker at the back end, and then that can pass that information on to another client. Now this actually is a real case scenario, and this is actually derived from, it's a cable network provider, but this is a general kind of scenario anyway, but one real use case is this cable network provider in the US. They want the ability for people to be able to change channels using their mobile phone. And if you think about it, what they've got to do, they've got to have an app on their mobile phone, which is going to select the channel. That's going to go and talk to their back-end web server. That back-end web server's got to then know exactly what set-top box they're on and send that information to them as quickly as they can. I mean, set-top boxes don't actually have a lot of memory. They don't have a lot of bandwidth to do much, so we're going to send that out to a gateway. So we're going to send that over AMQP, and we are doing that. And on the gateway, we're going to be having AMQP talk to MQTT to the actual set-top box to change the channel. You think about how quickly we've got to do that to be useful to someone who is scrolling down channels and changing the channel. Right, so I'm going to try and do a simplified demo first. We'll just show you this all in Java code. So at least I can show you something which kind of works. So the first thing I'm going to do is just show you the, what I can. So this is the gateway configuration. It's probably a bit small. But basically the most important thing here is these two lines at the bottom, where you can see the protocols I'm using. One's so I'm listing on 2 ports, one's listing for MQTT, or 1883, which is the default for MQTT, and the other transport connector is listing on AMQP. Now, a critical thing down here is I'm actually importing, on that line down there, I'm importing a bit of camel XML. And that camel XML is actually just doing a very simple route. What I'm doing this route here is taking messages off the topic. So MQTT only talks on topics, doesn't talk on queues. ActiveMQ internally does translation automatically between MQTT, JMS, AMQP, Stomp, etc. Every protocol it supports does automatic translation anyway. But what I'm going to do is actually take that message off that particular topic and then put it onto a queue. Now this audio queue is going to be sent over AMQP. Now on my second broker, it's called a broker, let's scroll down the bottom. I've actually got 2 connections there. I've got just OpenWire, which is default, and I'm also going to provide WebSocket implementation too. And that also includes a camel route, and that camel route is going to be subscribing from a JMS queue and then broadcasting it out onto another topic. Now the key thing is here, the actual connectivity I'm doing is with, is actually this one down here, where I'm using JMS to subscribe over AMQP. So what I've got is a gateway talking on AMQP and another broker connected to that using Camel to communicate over AMQP, pass it into a Camel route and then broadcast that back out again. Sounds simple, doesn't it? Okay, so my gateway's already running. I'll start the broker up. That's going to hum along nicely. So let me show you what the consumer and producer do. I've just got a normal JMS consumer which is going to connect to the broker which is using OpenWire and just consume messages. And then I've got an MQTT producer which is going to talk to the gateway. It's using an MQTT client library which you can find from FuseSource called FuseMQT or Client MQTT. And that's going to be sending messages. So I'll start the consumer up. That's all hunky-dory, it's sending messages. Great. So now I'm going to introduce some seat of your pants randomness. I've got a small device down here. It's, can you see that? It's called Arduino. It's an open source microprocessor. That's what it really looks like up there. These are relatively cheap, okay. And what's good about them, you can see these are like stacked together. So you can buy shields. So the basic processor itself is like $20. And the system's not that large, but it now allows you to pass in analog signals and allows you to program it too. But you can stack shields on top of it. The one on top is a Wi-Fi shield, so I provide Wi-Fi connectivity. And actually, programming this is a complete joy. There's no JVM on here. It's not like a Raspberry Pi. You've got 2K of memory space to actually program. So you've got to be quite efficient about how you do stuff. And I'll show you the, fingers crossed this doesn't blow up. So this is what the code actually looks like. It's a kind of a modified C. What's really nice about it is there's no heap. It's all in a stack. If you make errors, like it's no debugging environment, if you make any errors in your code, the only way you find out is because the Arduino are constantly recycling reboot. So you know something's going wrong there. So it does take a while to figure out what's going on. But this first section of code, I'm sure you can't see that well, that's just me connecting to the Wi-Fi network. And then there's an open source Mqtt C client which I've incorporated. And this program itself is called a sketch. And you upload this program onto the ROM on the Arduino via USB cable. I've already done that to date. So that's going to be hopefully far along nicely. And then just to show you what's going on. I'm going to use disconnect. So I'm just starting Jetty so I can use Hotio. Hotio is an open source project. It's going to become the default management console for ActiveMQ 5.9, and it's also the basis of our product, the Fuse management console, when it rolls out in JBoss A-MQ and JBoss Fuse 6.1. Is that you can connect to remote devices. So I'm going to do that now. So remember, I've got a gateway broker running, and I've got a broker running. So, 6.3. So connect to the gateway first. Okay, so I can look at, see what's running on ActiveMQ. And I've got a QMR audio. But what the really fun thing is that I can also look and see what the camel route is actually running on there too. So this is on the gateway. And gives you a nice diagram of what's actually running inside that broker. And these numbers should update. This thing's working. So let's connect to the broker as well. I suspect that this isn't working for some reason. Try to reboot this. Okay. Let's forget the battery and go fill in. So let's go and see what the Arduino is actually doing. So at the moment it's trying to connect to the wireless network. Which can take some time. It's pretty slow. It's connected. MQTT is connected. Okay. So it says it's running. Yes, you can see update encounters. I've also got the last broker is talking over WebSockets as well. So it's a small JavaScript client I've written using Stomp, which is doing what that will do is actually pick up information from the Arduino, and the Arduino takes an analog input. I've actually connected a small microphone, because normally when people demonstrate an Arduino it's actually measuring temperature and stuff, which isn't very dynamic. So at least if you're connected to a microphone you can pick up sound. So we should start picking up sound. So try and make as much sound as you like and see how the graph goes. So it's a bit laggy, it's never mind. So that's it.